Hello, Year 3, and thank you for joining again for our next maths lesson. As always, I'm going to start by sharing our screen so we can work through it together. Yesterday, we did scaling problems, where we looked at comparisons between groups and how many times more one group has compared to the other. For example, if one person has 3 snowballs, the other person has 6 snowballs, they have twice as many. Now, today we're going to move on to solving combination problems. And again, I'll explain a bit more about what that is in just a moment because it will be easier when we see an example. To get us started though, first of all, I want you to practice counting up in 4s from 4 to 40. You can either write this down or you can say it aloud. Complete these repeated addition calculations. So what is the total for each one? And then complete those multiplications. As always, feel free to pause the video, work through those, and we'll come back together in just a moment's time. Let's come back together there. The first one, counting in 4s from 4 to 40. Let me do it on my screen so you can see it. 4, 8, maybe you can count along if you know it. 12, 16, 20, 24, 28, 32, 36, and 40. Well done if you managed to do that without having to check any of those times tables as well. Next one, I've got 3 plus 3, or 2 times 3, which is equal to 6. After that, I have 3 plus 3 plus 3, which is the same as 3 3s, or 9. And then 3 plus 3 plus 3 plus 3. This time there are 4 3s, or 4 times 3, which is equal to 12. Just below, 8 times 1 is 8. 8 times 2 is 16, and 8 times 3 is 24. Well, they don't quite line up. Let me move them a little bit. Over here, 8 times 4 is 32, 8 times 5 is 40, and 8 times 6 is 48. A bit of practice for our 8 times table is linking almost to our morning fluency as well. We're going to move on to solving some of those combination problems. To do that, I'm going to share a different screen, so bear with me just one moment. There we go. You should now be able to see a PowerPoint with a snowman on it. And it says at the top here, the children are dressing the snowman. They have 3 hats and 2 scarves to choose from. How many different combinations can they use? For example, they could have a blue hat with a green scarf, blue hat with a blue scarf, green hat with a green scarf, and so on. Can you work out how many different combinations there are in total? Maybe quickly get a piece of pen and paper, jot them down. You might want to lay it out in a bit like this. In fact, if I show you a few of them to help, I've got blue hat with a green scarf. That's that blue hat with a green scarf. I can also do blue hats with a blue scarf. I'll pause at that point, see if you can work out what the rest of the combinations would be. Let's look at them together then. So we've done all of the combinations for the blue hat. There's blue hat with green scarf, blue hat with blue scarf. I've done them both. So next I'm going to go on to my green hats, and I can combine that with the green scarf or the blue scarf. So green hat with the green scarf and green hat with the blue scarf. What's my last hat that I haven't done yet? It's my pink hat. And I can do pink hat with green scarf or pink hat with blue scarf. So pink hat, green scarf, pink hat, blue scarf. How many combinations are there in total? Can you count? Let's count together. So there's 1, 2, 3, 4, 5, 6. There are 6 combinations in total. And we can show that as 2 plus 2 plus 2 equals 6, or 3 times 2 equals 6. If we multiply these numbers together right at the beginning, we know the total number of combinations. 3 hats times 2 scarves equals 6 possible combinations. So we can show it by listing them all out, and we can also show it in those ways. Now, what if they have 4 hats and 3 scarves to choose from? How many different combinations will there be? Maybe this time, think about using that multiplication fact. Can you work out the total by doing 4 times 3? That should give you how many possible combinations there could be. And then if you've done that, can you record them into a table a bit like this? I'm going to skip back to give you a moment to do that. Let's have a look at that together. So I'm going to start with my blue hats. And I can do blue hat with a green scarf, blue hat with blue scarf, blue hat with yellow scarf. So let me show that over here. Blue hat with green scarf, blue hat with blue scarf, blue hat with yellow scarf. Which hat do you think I'm going to go on to next? Yeah, I'm going to go on to my green hat, and I can go green hat, green scarf, green hat, blue scarf, green hat, yellow scarf. Green with green, green with blue, green with yellow. Now onto my pink hat. Pink hat, green scarf, pink hat, blue scarf, pink hat, yellow scarf. Pink with green, pink with blue, pink with yellow. And lastly, I've got this greyish hat here. So I can do grey with green, grey with blue, grey with yellow, grey with green, grey with blue, grey with yellow. How many are there in total? We've got 3 for the blue hat, 3 for the green hat, 3 for the pink hat, and 3 for the grey hat. So again, we can use that calculation, 4 times 3, which gives us 12. And we can check that by counting these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 possible combinations. Last thing, Whitney is choosing a piece of fruit and a drink for her lunch. How many different possible combinations are there? So she's got, looks like a milk carton and a juice bottle. And then she's got banana, apple, pear, orange. How many different possible combinations can she make? I would be thinking there's 2 drinks and 4 fruits. I can multiply those together to get the total. 2 times 4. What do you think that could be? Let's have a look together at this one. So let me go back actually. We can see that together. So we can do the milk with the banana, with the milk with the apple, the milk with the pear, the milk with the orange. There's 4 already. The milk with each of those fruits. Then we can do the orange with the banana, the orange with the apple, the orange with the pear, or the orange with the orange. So that is another 4, which should give us 8 in total. 2 times 4 is equal to 8. In fact, there is one more for us to look at together. Dexter is choosing an ice cream. He chooses 1 flavour of ice cream and 1 sauce. So there are 8 different ice cream flavours. And there are 24 combinations. How many different sauces are there? We don't get told the flavours this time. We don't get told the sauces. We are told there are 8 different flavours of ice cream. We don't know how many sauces there are, but you can get 24 combinations. I wonder how many sauces that means there are. Maybe stop the video here, pause and have a think. How do you think you can work that one out? It's a tricky one. Let's look at it together. There are 8 different ice cream flavours, and there are 24 combinations. That's the important information here, 8 and 24. So we've got to work out 8 times something is equal to 24. 8 times something is equal to 24. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. So 8 plus 8 plus 8 equals 24, or 8 times 3 equals 24, which means there should have been 3 different sources available for that ice cream. Well done if you got that question. That problem was a little bit in reverse, and we had to think a bit differently about it. Let me start sharing a different screen once more so you can see your challenges for today. The first challenge. Dora is making ice creams. She has 4 flavours, and we can see them here: chocolate, vanilla, mint, and strawberry. And she has 3 toppings: nuts, chocolate chips, and sprinkles. Can you first complete the table to show all of the different combinations? And I've started you off with chocolate and nuts, chocolate and chocolate chips, chocolate and sprinkles. I'd next go to vanilla and nuts, vanilla and chocolate chips, vanilla and sprinkles, and so on. And can you think about the calculation we would use to work this out? If there are 4 ice creams and 3 toppings, what calculation will that be? Pause the video here, have a go at that one. Let's look at that one together then. I have completed my table. I won't read them all out, but you can see I did all of the toppings for chocolate first, then all of the toppings for vanilla, all of the toppings for mint, all of the toppings for strawberry. And the quicker way to work that out is just by doing 4, because there are 4 flavours, times 3, because there are 3 toppings, which gives you 12 possible combinations. Well done if you worked that one out. Let's have a look at another one together. This time there are 5 pairs of mittens. There they are. And there are 2 scarves. Amir chooses a pair of mittens and a scarf. How many different possible combinations are there? So I'll be thinking red mittens, purple scarf, red mittens, spotty scarf. Blue mittens, purple scarf, blue mittens, spotty scarf. Or think about using your multiplication methods. How many mittens are there? How many scarves are there? Times them together and you get your total number of combinations. Again, pause the video there. Can you do the table? Can you do the calculation to show those combinations? Let's look at that one together. I haven't filled out my table this time. I've skipped straight onto my calculation, and it's 5 times 2 because there are 5 mittens and 2 scarves, which gives us 10. If you filled out the table, you might have done it red mitten and stripy scarf, red mitten and spotty scarf, blue mitten and stripy scarf, blue mitten and spotty scarf, and so on to fill out all 10 possible combinations. Last one. This one's a bit trickier. This one, again, is a bit of a problem-solving one. Whitney buys a snack and a drink. Here are her snacks. So chocolate, muffin, cookie, and apple. Some tasty snacks there. And some drinks. She's got juice, pop, milk, or water. She thinks there are 8 possible combinations she could choose. Do you agree with her? Are there 8 possible combinations? And you've got to show or explain how you know, and maybe you can jot that down on a piece of paper. So let's look at that one together then. I don't agree with Whitney. I think what she's done is she's added them together. She knows there's 4 snacks and 4 drinks. So 4 plus 4 makes 8. But we don't add them together to get the total number of combinations. We times them, we multiply them. So she should have done 4 times 4, which gives you 16 possible combinations. Because you could do chocolate with juice, chocolate with pop, chocolate with milk, chocolate with water. Muffin with juice, muffin with pop, muffin with milk, muffin with water. Cookie with juice, cookie with pop, cookie with milk, cookie with water. Apple with juice, apple with pop, apple with milk, apple with water, which is 16 in total. Well done if you spotted her mistake there. As a challenge X, I want you to try and create your own combination word problem. Can you have a go at creating a similar style problem? And maybe you can send them in to the email address so we can have a look and try to solve them ourselves. That'd be a good little challenge for you and a good challenge for us perhaps too. Before we finish today, a fluency question for you. Can you represent 345 in as many ways as possible? I won't go through the question for this one or the answer for this one because there's lots and lots of different ways you can show it. So again, perhaps you can send some of your responses in. Thank you again for joining. I hope you've managed to have a go at some of those combination problems today, and I look forward to seeing you next time. Bye.